AQA A-level physics. This is for the astrophysics topic, and this is about the HR diagram, the Hertzsprung-Russell diagram. So now this is what the specification says, general shape of the diagram, blah, blah, blah. I'll be covering all of this, of course, in the video. So here we go. So what is an HR diagram? A Hertzsprung-Russell diagram. HR will do, and it's a graph, and it shows the relationship between the apparent magnitude, which is otherwise known as the luminosity, how much light the star gives off, and the spectral class, or the temperature, for lots and lots and lots of stars. And when we plot magnitude against temperature, we see some very interesting patterns. Different types of star appear at different places in the graph, and it very much helps us to understand the evolution of stars. In other words, the life cycle of stars, how one type of star changes into another. Okay, so this is the HR diagram. Now, at GCSE astronomy, you might be asked to sketch it. You certainly need to identify the different bits of it and understand the scale. We'll see. So I'm going to start with my axes here. Now, on this axis is magnitude, which, as I said, is basically how much light the star is giving off. Its luminosity. The very, very brightest stars, -10, and then the dimmest stars about +15. Okay, remember absolute magnitude. I've covered that on another video. So it's basically brightness, how much light the stars give off. The other scale, the x-axis, is temperature. Now, one thing to note on temperature is that it's not cold to hot, it's hot to cold. So the very hottest stars, which are about 50,000 Kelvin, are down there, and the much, much cooler stars, I'm not going to call them cold, about 3,000 Kelvin, or I believe the specification says 2,500 Kelvin down there. So it's temperature, but from hot to cold. What we can do on this diagram, in my last video I talked about spectral classes, is put this down, the Oh Be a Fine Girl Kiss Me, the different types of star. Okay, and the hottest star are the O's, and then the coolest stars are the M's. So we could actually put that down. It's not exactly evenly spaced, but it gives you an idea of what this axis is all about. So there's lots and lots and lots of stars out there. We have lots of information, and we know their temperature, and we know their magnitude, and we plot them on this graph, and what we find is this. Okay, so stars fall into these four main groups. Now, technically, AQA A-level physics, you actually only need to know 3 of them, but I think it's a shame that the 4th one's missing, and it won't do you any harm to know it. Okay, now what are these 3 groups? Well, this big sausage down the middle, yes, this big sausage down the middle is called the main sequence. So that is the main sequence. Okay, I'm just going to call it MS for now. Now, it isn't a sequence, okay? It is just where in the middle of their life cycle, most of the stars happen to be. It's where the sun is, lots and lots of stars in this sausage in the middle called the main sequence. Okay, the stars are quite happy, they are stable, they spend most of their lives in there. Our sun will spend about, 10 billion years in the main sequence. This above it, the blob above it, are your red giants. So they are your red giants there. Okay, much, much bigger stars, much cooler stars later on in their lives. They are quite bright. In other words, they give off lots of light because basically they're very, very big. Not because they're very, very hot, but because they're very, very big. Kind of the opposite of that is bottom left here is we've got our white dwarfs. Okay, now they don't give off a lot of light because they're not very big. Yeah, their surface area isn't very big, but they are very, very hot. So they are our white dwarfs. And then up the top here, this is the one that strictly speaking you don't need to know, but they are your supergiants. So supergiants up the top there. Very, very big stars. Red supergiants, blue supergiants are also very, very hot. Very, very big, very, very hot. Okay, red supergiants, very, very big. Bright because they are big, but not necessarily very hot. Okay, so these are the blobs that you need to be able to recognize. I've seen a couple of questions where it gives you this chart and you have to identify what these different blobs are, these different areas on the graph. Now, the sun is there. It's a G-type star and it's in the main sequence. Our sun is about 5 billion years old. In another 5 billion years, it will change into a red giant. So our sun is kind of middle-aged, and that is where our sun is on the HR diagram. Now, the evolution of stars like our sun, well, this is, in fact, before we come to that, this is a kind of HR diagram that I got off the internet. There's loads and loads of them. Have a look at a couple of them. You'll see that your diagram doesn't have to be exact if you're asked to sketch it, which you probably won't be. But this is an HR diagram off the internet. You see the 4 blobs I was talking about. Look at the axes. So at the bottom, you've got temperature. Here, they just call it spectral class. And then you've got absolute magnitude up there on the left. Now, the evolution of our sun. On my GCSE physics site, you did this at GCSE, revise it. Remember our sun, and you may get asked this in an A-level question. If you do, it's easy marks, should be. Remember nebula, protostar, main sequence, red giant, white dwarf, black dwarf. Okay, nebula, big cloud of gas, comes together by gravity, protostar, it's getting hotter and hotter and hotter. Fusion hasn't actually started yet. Main sequence, that's in the middle of its life. Fusion is ticking over nicely. Red giant, the hydrogen has started to run out and stuff is happening in the core and it blows up like a balloon, etc. And then it shrinks, gravity pulls it in, you get your planetary nebula, you get your white dwarf in the middle, and then after a long, long time, you end up with this, when it's cooled down, you end up with a black dwarf. So this is stars like our sun. On the diagram, now what happens is, let's change color. Our sun comes onto the diagram from over here. So it comes onto the diagram, does a little bit of a, don't worry about it, but that's where it comes from, okay? Around here it's a protostar when it's actually becoming a star. So it's a lot cooler, and then it shrinks, and so it gets hotter and hotter. And there's our sun on the diagram. When our sun, as I said, starts to die, it will become a red giant. So it moves up to there. And then when it cools down, it will come from red giants way down here, down to white dwarfs. Okay? And that's what we need to know. Okay, that's the evolution of our sun from a protostar to a white dwarf.